Thanks, Phil. It's always great to be at these events. I've been coming for about 2 years now, and I recognize actually a bunch of faces in the audience, and that's really cool because, of course, the space we're in, technology, trying to drive the transformation of our businesses, on the one hand, moves very quickly. And I think back to even the presentation I gave at the similar ET Exchange event a year ago, how much things have changed in that last year. It's incredible, right? At the same time, things change far too slowly, right? Back to the question about agility a second ago. How can we move more quickly, right? How can we keep up with what's going on? How do we keep up with China? Like, I just got back from China and Japan. I was there for 2 weeks. China is moving at lightning speed on all of these areas. Why? Because they have a lot of reasons, but one reason is they have very little legacy, right? They're starting basically from scratch with these new transformation initiatives. In fact, they're not transforming things. They're just starting. What an advantage to have. But we have to meet that challenge, right? We have no choice. So that's what we're going to talk about today. Stephanie, thanks for that intro. You'll see what she just talked about for the last half an hour is really exactly what I'm going to take from here on and maybe make a little bit more specific in terms of a particular core technology or a way of thinking about applications that I think you should be thinking about increasingly as you're trying to drive the transformation of your organizations. Tomorrow we'll talk about VANTIQ, we'll show you demos and use cases, and we'll get into that. This discussion here isn't about VANTIQ, it's about the concept, what's behind VANTIQ, this notion of real-time event-driven systems. So before we get into that, I just have to say a big, I'm so excited about my Toronto Raptors. Woo, NBA champions. Yeah, exactly. All right, I am a Canadian originally, but I live in San Francisco, so I'm also a Warriors fan. So I was actually winning no matter what happened. But if Toronto hadn't won, I would have had to have worn a different jacket. So I'm wearing this. Thank goodness. Good work, Toronto. All right, let's dive in. So this first slide is probably the close parallel to a lot of what you just heard. A lot of these technologies are coming at us so quickly. AI, machine learning, it's now being embedded inside everything. We don't even think of the devices and cameras and sensors that now have machine learning and AI built into them these days. It's not a separate thing you add on after. It just increasingly comes with things. IoT, a huge driver, and edge computing. Again, 2 years ago, doing stuff at the edge was in the lab. It was a science experiment at most organizations. And now driven a lot by IoT and some other forces we'll see, it's coming out of the lab into the real world very, very quickly, right? And Stephanie talked about a lot of these drivers of business model change that the technology is causing, right? Companies want to buy outcomes. They don't want to buy products anymore, and increasingly they're buying them as a service. They're subscribing to them, right? And these products are increasingly mixing the physical world and the virtual world together. But when I think of the overriding trend, the one that is most responsible for most transformation these days, it's the mindset shift from doing things in batch mode to doing things in real-time mode. And fundamentally, when you think about it, any application which is built around putting stuff in a database in order to do a report or take action later is a batch mode mentality, right? As opposed to sensing what's going on in the world in real time and taking action as it's happened. Fundamentally, Uber disrupted the taxi industry by turning the taxi business into a real-time business, right? Knowing the real-time location and status of all the passengers and cars in their entire ecosystem. Most fundamentally transformative businesses today have done that by doing that same thing. So that's how you build a transformative business model, by thinking through some of these business changes driven by technology. Of course, it's not easy. It's complex. We have to be increasingly agile. We have to run at speeds we haven't run before. Why? We've got software throughout our organizations, a lot of new technology, IoT, AI, NLP. We talked about a bunch of those just now. Human-machine collaboration. I'm so glad that was twice on your slide, because human-machine collaboration is absolutely critical to drive the effectiveness and efficiency of our organizations, which still are mostly made up of people these days interacting with systems and machines. And then finally, legacy technology, legacy applications. Many of you are in organizations where you've got 20 or 30-year-old systems that you're still using today to drive your company ahead. You can't just turn it off. So how can you bring those systems up to speed, connect them into real-time systems, bring the company into the next generation without having to just turn all these systems off? That's not easy, right? To be able to sense what's going on in your business, analyze it, and act in real time. Well, as I said a second ago, probably the way not to do it, the thing you're trying to figure out how to jump from, is standard 3-tiered database-centric architectures, where again, what you do, the goal is to put everything in a database or a data warehouse or a data lake, or it'll be a data ocean very soon, and then do something later. You have to figure out how to run your business in real time. And I believe, and lots of others are obviously talking and writing about this these days, the notion is with something called event-driven systems or event-driven applications. That's how you can cross that chasm. I do a demo, but I sprained my ankle the other day, so we won't jump over the chasm. So what is a real-time event-driven application? Well, think of this system at the core here, and what it's doing is it's taking all this data coming from IoT devices, from enterprise systems, spitting off your ERP system, your employees working on their mobile devices, the millennials that are all mobile. And what is that data? It's data about the events that are happening in and around your business all the time, right? The location of people and machines, the status of systems, alerts, conditions, all of that is what we call event data, and it's flowing in real time. We have to take it, be able to ingest it and process it. But of course, the applications you build or you stand up have to understand some context, right? You need to know if a temperature is above 100, is that good or bad? If a car is located here, is that where it's supposed to be or not? So you have to have some intelligence, some context in the application. And then here's the secret part, right? Shouldn't be a secret, but many of these systems stop at reporting and alerts. They create really nice dashboards, dancing charts and graphs showing the status of machines and the location of things. But the real power, the real benefit to the business comes when you actually take actions in real time, right? When you, based on the real-time status of your system, you move a person somewhere else, or you turn a machine off, or you do something in real time as the data is flowing. And of course, the actions are also events. So it's not a left to right flow. The actions are events, and when you take the action, you're changing the state of the system, and then that's why this has to continue back and forth. So I wish I'd seen Stephanie's presentation before I created this a week ago, because all my Gartner and IDC quotes, I could easily say Compass Intelligence here, but I'm a former Gartner guy myself, I'm a Stephanie person. So anyway, Gartner, Stephanie, IDC, many of the others are doing a lot of writing about this concept, and fundamentally that EDA, event-driven architectures, event-driven applications need to be core to the vast majority of digital transformation initiatives. So let me give you an example event-driven application, and I'll try to make this a little bit more specific. So suppose you've been tasked with doing real-time field service, safety and security management of the elevator system in your city. And so you've got elevators putting off data. The average elevator now has over 100 sensors on it. If your elevator is putting off one data point every second times 100 sensors, you realize there's 2.5 million seconds in a month. Okay? So there's no way, even if you just got 100 elevators, you can put all that data into the cloud. It's impossible. And why would you, right? Because most of the data is temperature 72, temperature 72, temperature 72. It makes no difference. Process that on the edge, get rid of it, throw it all away, and only keep the data and process in the central application in the cloud the stuff that matters, the events that matter. So you push those into the cloud, or maybe it's in your private data center, wherever your core application is. Of course, that application understands the external context. Maybe it's connected, in the elevator example, it's connected to a weather data feed. So it knows if it's 120 degrees outside, that elevator probably will be. In fact, it might predict that it's going to get hot and proactively increase the AC in that elevator. And then finally, enable, again, that real-time action by people and machines working together. So proactively send out a field service agent if a problem is going to happen, alert a security guard if somebody has fallen down in the elevator using pose estimation technology, which is getting very common these days. So this is an interesting sort of end-to-end application of an event-driven system. Now, these systems apply to really every industry. Many, many different types of use cases are being reinvented now as real-time applications. I want to give you, so in tomorrow's case studies, we'll show you many more specific examples and real applications running. But I do want to take a second and show you this video that I saw recently from Rolls-Royce. Maybe a few of you saw this. Now, this is their vision video. They're not, I don't believe they're actually running this system yet. And you'll see they've got an amazing marketing budget to be able to produce this kind of content. But I do want to point out that while the production value is very high, almost everything you see in this video, this real-time event-driven application you see in this video, is absolutely doable today, right? You're going to see a real-time event-driven system, large touch screens in various sizes. We've got a 100-inch touch screen at VANTIQ right now in our boardroom. Text to voice, very easy. We've been doing that for a decade. Natural language processing, speaking your commands back to the computer. Again, getting very common. GPS tracking, AR, video overlay on top of videos, becoming very common. Drones, facial recognition, eye tracking. All of these things are doable today, and we're running many of these systems today. Our clients are running many of these systems today using all of these technologies, right? There's one thing in this video you can't actually do today, okay? This is the one thing you can be skeptical, where the commander there has a floating 3D hologram and he shoots it away with his hand. We haven't quite got to the 3D floating holograms yet unless you're wearing HoloLens or some other AR rig, right? The only thing that's not today about this video is the floating hologram. Everything else we can do today. So let's take a look.
The control room is the nerve center of remote operations in the Rolls-Royce OX concept, where the global wall shows a real-time overview of worldwide shipping traffic. A full situation overview is presented to operators who are monitoring vessels via remote link from their onshore workstations.
Dynamic Positioning Reports DGPS-1. Lost connection for vessel RR9835. Suggested course of action. Diagnostics. Commands?
Proceed.
GPS, geopositioning and celestial navigation status. Nominal. INS status. Transmission stopped. Suggested failure mode, physical. Commands?
Stand by. I'll have a closer look.
Drones 01 through 08 ready for inspection flight. Commands?
Launch drones 1 and 2. Flight plan. Standard inspection routine. Camera control. Manual with eye track. Deploy replacement for selected antenna. Schedule post-mortem inspection and change of antenna at next port of stop. Add checkpoint for operator at selected time. Verify navigation data integrity.
The vessel is ready for handover to local operator at West Coast VTS. Transferring administrative documents. Suggested course of action, break and refreshment.
Okay. Leave the documents open when they're ready.
Confirmed.
All right, I want the virtual cup of coffee. That's pretty cool. But other than the virtual coffee and the floating drones, again, you know, if you subtract away the captain's chair and the amazing graphics that took, you know, that would take some amazing graphic artists to create, the fundamental technologies, the fundamental use cases that he's doing there, this real-time, which is really a real-time field service application, enabled by IoT, AI, drones, et cetera. This is absolutely, totally doable today. I know it is because we have clients doing very similar things today. So the elements of a real-time event-driven platform are at its core a complex event processing engine, something that is able to do this processing of the data in real time, enabling mission-critical systems, and we'll talk a little bit more about each of these, that are able to run anywhere and be distributed if necessary, that enable that powerful human-machine collaboration we've been talking about, and then finally make it easier and more agile to do these things so you don't have to spend the next 2 years in the IT lab building that system you just saw. So let's dive into each of these in a little bit more detail. So fundamentally by now I think you've got the concept that complex event processing, event-driven architectures, applications created with that at its core can do some very interesting real-time use cases. And again, Gartner says by 2020, which is actually not that far away, half of all new user-facing applications will be written as event-driven systems. They have to be. It's the only way you can effectively support these kind of use cases like the one you just saw. The next issue is mission critical. This is really interesting because Stephanie talked about serverless computing. You know, loosely coupled serverless application platforms as a service allow you to build systems that are not POCs in the classic sense. I almost hate to use the word POC. It's like a swear word to me because we generally think of POCs as being a quick and dirty thing you do to show that something could theoretically be done, and then you throw it away and begin the long, hard task of building the real application, right? But with the new application platforms and the systems that we're talking about, you build right from the get-go a secure, scalable, always-on available application. It may not have many features. You have time to add more features to expand the use cases, you know, over time. But to build a throwaway POC, given the state of today's technology, is, I think, actually ridiculous, enabled by the technologies that we now have at our disposal. Distributed computing, edge computing, and the ability to run anywhere, those are sort of a few, they're related but different concepts. First, the fact that we know many of you are running hybrid infrastructures today. You're running some applications in the public cloud, maybe some in your private cloud, some on your bare metal data center. That situation isn't going to change for quite some time, and so you need platforms and tools and technologies that allow you to do that. Then there's the issue of edge computing, again, itself, which again, a couple of years ago was truly in the science experiment phase, but we're seeing it more and more, especially driven by IoT, like the elevator example I gave you, but many other things are now smart city, smart building applications. A lot of these things just require people to think about edge computing from the get-go. Human-machine collaboration, I think we've talked about that throughout this whole presentation, and we've seen you know, the improvements in productivity you can get from having people and increasingly intelligent machines work together effectively is very, very real. I'd love to show this picture here. So those who didn't see it before, does anybody know what this is a photo of? This is a photo of the Tesla Model 3 assembly line. Okay? So I bet most of you assume that Elon Musk's Model 3 assembly line would be a lights-out facility with a bunch of computer-run robots all just popping these Teslas out the other end, right? And that was his original vision, but what he quickly realized is to get the production volume he needed to get, he needed people and machines working collaboratively and closely together. So if Elon Musk needs that many people in his factory, our people aren't going anywhere anytime soon. But they do need to be able to work effectively in real time with these systems, whether they're hardware systems and robots or software systems. Okay, so all that's good, and in reality, many of you have been around a while, you know that event-driven applications is actually not a new concept, all right? It's been around, the concept has been around for decades. The challenge is these things historically are very hard to build, right? Why are they so hard to build? Well, you're taking in asynchronous events coming, in any order at any point in time. You have to have systems that can handle those, called reactively. Reactive programming, very complex. Streaming data in, sometimes in massive volume, in real time, requiring distributed systems. And then you got people. And once you put people in anything, it just becomes twice as complex, right? Robotic process automation is cool, it's very valuable, it's about taking people out of the process, but many processes and systems you just cannot take people out of today. So to build that kind of system, historically, you had to do something like this. Okay, this thing in the middle here is the real-time architecture of a real-time supply chain application by a global retailer who you all know very well. I can't say the name. And you can see they've got sort of the core IBM platform they're using, and then a bunch of very complex technologies, Kafka, Nifi, Cassandra, et cetera. To the question about teams getting smaller and smaller and being asked to do more and more, if you were trying to stand up an application, maybe this company could do it. They probably had 100 people working on this project for a year, right? Most of us aren't in that situation. We need to basically take all that very complex technology stack that needs to be optimized and upgraded and tweaked. If anybody's played around with Kafka, you know it is absolutely a non-trivial technology to tune and to get working at any scale whatsoever, right? So most of us, even if this company, when they built this a few years ago, had the resources to do it, I guarantee they no longer have the time to do another one of these. They need to be able to do this kind of thing in weeks or a few months, not in years. And so here's the good news. Real-time applications are actually not any longer hard to build. They're now as easy to build as standard 3-tier applications have become. Why is that? It's because this notion of so-called low-code, no-code, high-productivity, rapid application development tools that have been around for 15 years now, and I think starting to become really perfected in the last 3 or 4 years, that notion is finally being applied to the domain of event-driven applications. So now you can not only build a nice web UI for your ERP system or modernize some standard database-centric application using a low-code rapid app tool, and I know you're familiar with many of them, because they're increasingly coming into IT organizations, you can now build these next-generation systems, these next-generation real-time applications like we've been talking about with the same low-code, no-code, very agile, rapid application development tools. And that is quite recent, and that is, I think, very cool and very important to us really being able to drive agile, quick digital transformation. Again, guys, IDC, fundamentally, if you want to be able to transform your organization in an agile way, you have to be thinking about using these tools. All right, and just a quick comparison using current methods to do this kind of thing, a team of developers, thousands of lines of reactive Java code. This is very complex to stand up compared to, applying, again, the principles of rapid application, low-code development to event-driven systems. Having said all that, I think it is very important to always have the mindset, and sort of in answer to one of the earlier questions, start small, and that's how you're able to be agile. Pick a very small use case. Don't start trying to transform 250,000 elevators, but just start with one building and 20 elevators, right? And get that working, drive value to that by managing them in real time, predictive maintenance, proactive security, and then expand to the next set of elevators. And eventually you'll get to the 250,000, but you don't want to start with that. And same with most of these use cases. Start small. That will allow you to drive business value very quickly and be agile like you need to be. Now, I'm actually not going to dive into this. Tomorrow in the use cases and case studies, I'll dive into some of these case studies. Just very quickly, Inessa, the second one there. They're the organization that is building the system for the city of Shanghai to manage all 250,000 elevators in the city of Shanghai. Only in China could you do this. Every commercial elevator in Shanghai will be monitored and managed by this application being built by Inessa. But they didn't start with 250,000. They started with 10. So that would be it. So we'll talk more about these tomorrow. So that's me. I hope you enjoyed the quick discussion about real-time event-driven systems, and we got 5 minutes for some questions. Come on, Isaac, Ken, I know there's some good questions out there. Ah. So the question was, how do you like to be the CISO that has to protect the application that's connected to every elevator in Shanghai? That's a really good point, and I'd love to be that CISO. Actually, that would be an amazing job. But I think the point that's really important, and we can talk a little more tomorrow, but again, when you think about doing a POCs, I bet very few POCs you've ever built in your lives are secure, okay? You think of security as something you worry about when you build the real application later, right? And using some of these new platforms, you can build secure applications, encryption, authentication, all the latest technologies related to security right from the get-go at the so-called POC stage. So I guarantee when these guys built the application for 10 elevators, it was a secure application. And you know, it'll continue to be as they expand. Yeah, oh, there's Isaac in the back.
Hey, Blaine. What should we say to the developers who want to play and use Kafka and Spark and try to use all the tools that are out there and really experiment when there are other platforms that they can use that have security and have low-code capabilities?
Yeah, really, really good question. And in fact, these systems like VANTIQ, we have native integrations to Kafka and many of these other technologies that we talk about. So on the one hand, I say it's very quick and easy to build, you know, systems in these all-in-one application platforms. But almost all of the enterprises we work with have these kind of technologies already in them, right? Whether it's Kafka or different databases, IoT device management systems from Azure and HP and all that. So it is very important. None of these real-time applications live in a silo by themselves. One of the biggest jobs is always connecting them into other systems that already exist to try to turn legacy systems and data sources into real-time systems. I badmouthed databases earlier, but of course you need databases. You need databases for certain kinds of applications and systems, and you can connect your event-driven system to those systems that use databases. Yeah.
One of the things, or questions I had is, when you talk about automation, and as I think about it, we do a lot of automation where we are. One of the challenges that we have is because of the data protection, you know, laws and things like that, and we work with the global system, the multiple support layers and having to ensure that things, you know, you don't really know which layer the problem is, and that takes time. And I think one of the things that we're having a problem is trying to organize that support layer to make sure that the real time is actually real time, because in some cases, because of the multiple integrations and the multiple teams involved, we get caught up and it causes delays. So yeah,
great question. GDPR is something that's always rolling around in my mind. We also see, you know, many of the builders of these kinds of applications are still running them in the private cloud or in their data center. They're not ready to put these truly mission-critical systems in the public cloud yet, partly for data privacy reasons and reasons of data control, and that's perfectly fine. These platforms don't force you to be in the public cloud. You can run them anywhere you want to run. I think, you know, fundamentally, you can build, you know, very secure systems that protect your users' privacy and put all your HIPAA policies and everything around it, or you can build the opposite. You know, that's up to you. What I would recommend people do is build them quickly, get something out there, show value, and then that'll give you more time to think through some of these larger issues which sometimes get pushed to the side. Yeah.
Shift traditional application development, or what's considered traditional application development, out of IT. That now it's not IT that's making these proof of concept applications, but it's what we consider traditional business power users.
Well, in my experience, IT, even if you can be a citizen developer to maybe build the core functionality of the application, using even some of the no-code parts of the system where you're literally using English to describe the application and you can start building the framework of the system, you know, I could do it, right? Eventually, there's always going to be integrations to other enterprise systems, legacy data sources, whatever the case is, and that always requires IT. So successful projects that I've seen are a collaboration between the business side and the IT side. And it's usually the IT side or maybe an external systems integrator or somebody working together with the business. But IT is always involved whether or not there's an SI. I've never seen a successful project that doesn't involve IT fundamentally. Yeah, yeah. It's a very big question, and even VANTIQ with my chief marketing officer hat on, I also directly face the question, should I be talking to IT about this? Or should I just be talking to the business side, the line of business, the head of field service, the head of manufacturing? You know, they're the ones that are running the business, that own the budget. You know, maybe I shouldn't even be talking to IT. And the reason I'm here right now talking mostly to IT is exactly what I've learned is it does take two to tango really effectively. Like the line, whoever, you know, I think in general we're seeing the line of businesses coming up with the idea first. Wow, we have to rethink how we're servicing all these elevators. It's not IT coming to the table with that idea. It's some, you know, it's the head of elevator field service that's coming to the table with the idea, but then they involve IT. I do believe, though, personally, that IT needs to become data generators, right? Idea generators, not data generators, idea generators. You need to bring these ideas to the table, to the business side and say, look what we can do now. You know, like that thing in that Rolls-Royce video, we could do 3 parts of that within a couple of months. Wouldn't that be amazing? Couldn't that transform your operation? Absolutely, I think IT should be bringing that stuff to the business side and not waiting for business to.
Last question.
All right, I think last one, yeah.
So I see a new challenge emerging. In this everything as a service model, we become more and more dependent on other organizations and their platforms. We're finding the same trend, keeping up and doing native development in the cloud is becoming difficult, and so we have to layer these platforms together. But what we've also begun to see is a trend where the CEOs of these different businesses or services also use that platform for their political views, sometimes for social views. Salesforce was a great recent example. And so there's a new type of risk being introduced in this, and an organization can start and begin to integrate and layer, and then that risk materializes, and it can be challenging to make shifts. What are some of your thoughts and recommendations in how to manage that moving forward?
Yeah, it's a really great question, very timely these days with everything that's going on the social media side, and then not even only social media, but as you said, Salesforce and others. I think there's, no matter what tool or solution you use, you're always to some degree getting locked into that. Okay? It doesn't matter, even open source solutions, right? You're putting in, you know, a lot of money in terms of training and services and everything else in that solution, and who's running it? It's a group of people that you don't know that could decide to push that technology in one direction or another. So that kind of risk exists with every tool or solution, I would say. But fundamentally, as long as the tools you're using are open, they're able to be integrated with other systems, you're not caught in one place. Salesforce isn't the only game in town, right? Like, there are alternatives to Salesforce. And that's why, you know, if you've decided that the core operating system of your company is Force.com applications, then you probably have to pay more attention to what Benioff thinks. But I think the reality is we are going to have an ecosystem of various tools, technologies, platforms, all working together. And that's what's going to be most effective for you, not to try to do everything with one. Great hard question, though. All right, thank you so much.
Thank you very much, Blaine.